Hi, everyone. This is the Hungry Math Professor here. Welcome to my channel. Today, we're going to be discussing set theory and its philosophy by Michael Potter. It has this nice um, cover that is unusual for math and philosophy textbooks, which is nice. This book was published in 2004, and in the preface, the author talks about and reflects on who this book is written for, and he admits that um, there's sort of two audiences that this book is written for. It's written for mathematicians who have an interest in understanding the philosophy of set theory as a foundational tool to understanding mathematics. And then it's also written to philosophers who have an interest in mathematics and getting into some of the technical details. And he admits, though, that those two groups may not have much, like there may not be many people in those groups, right? Because you have to be a philosopher who's willing to do a lot of mathematics, or you have to be a mathematician that's willing to do a good amount of philosophy, and those tend to repel each other. And so he just reflects on that a bit, and but he also thinks it's an important intersection to write a book about, which I agree, especially when it comes to set theory. If set theory is going to be a foundation for mathematics, or at least that's one way of thinking about set theory, then there's lots of philosophical questions that come up about how successful of a foundation it is, and in what senses is it not successful, and so on and so forth. So, it's a very important to think about sort of how set theory plays that role. And I really enjoyed this book because it does sort of fill that void of combining those two things. Other set theory books that I've read that I will talk about at some point on this channel do usually talk a little bit about philosophy, but they like in the preface or the introduction and things, but then they usually eventually forget about it and move on to just doing set theory, and then maybe they'll bring it up from time to time in short paragraphs where it becomes relevant to what they're talking about. Nothing wrong with doing that because set theory is its own field at this point, and so there needs to be textbooks devoted just to the study of set theory in and of itself. But this book plays an important role. Anyway, he thanks the publisher for not being so worried about the potentially small audience that this book attracts. Now, the book is broken up into four parts, and the first part is called Part One, Sets. And here, he has to do some work to just explain what it is that we're trying to do when we talk about sets, right? And he talks about what we now usually call naive set theory, which is like the set theory that Frege and Cantor were working with. Naive sounds maybe negative or condescending, but I think it's more just a point. It's a word used here to talk about the fact that at some point in history, we all were naive to some of the issues that were going to come up. So it's not necessarily derogatory towards Frege and Cantor. It's just more of a description of sort of where we were at that point in our understanding of set theory. Um, but he also, when you talk about sets, maybe you introduce sets to your students or something. There is this tendency to start with something very intuitive, right? Talk about collections of marbles or something, and that's what we are trying to capture when we talk about sets. There's something very intuitive there. But as we study this naive set theory, we're reminded of Russell-Zermero's paradox, this idea that we can't just form any sets using any predicates that we like, because otherwise we run into to this paradox. And so, after we as like in the communities, discover this discovered by Russell and Zermelo, pointed out. Now there's a desire to um, come up with the correct or come up with usable axioms for set theory, right? So I want to read a quote about this part because in this part of the book now we're going to try to describe the axioms of set theory, and he talks about how there are two strategies he calls regressive and intuitive. So the regressive strategy takes the purpose of the theory, meaning the theory of sets, to be the formation of a theoretical foundation for mathematics, and regards an axiomatic base as successful if it is strong enough to generate as theorems those results that we already believe on other grounds to be true, but not so strong as to prove those we believe to be false. The attitude is frankly pragmatic. One cures the visible symptoms of the paradoxes, but neither diagnoses nor attacks the underlying disease. According to this view, then, the object of a good axiomatization is to retain as many as possible of the naive set theoretic arguments which we remember with nostalgia from our days in Cantor's paradise, but to stop just short of permitting those arguments which lead to paradox. Right. So he talks about how it's pragmatic, in some sense, in just trying to capture the mathematics that we already believe to be true, but also to capture, a lot of the advantages that were brought about by sort of Cantor's ideas. But then he also describes the intuitive method. So the intuitive method invites us instead to clarify our understanding of the concepts involved to such an extent as to determine the axioms they satisfy. The aim should be to reach sufficient clarity that we become confident in the truth of these axioms and hence, but only derivatively, in their consistency. Right. So these are two different strategies of how you might approach trying to come up with the axioms of set theory. In this book, he's going to mostly focus on the intuitive version because I think because he wants to discuss philosophical arguments, and it's the intuitive approach which is more open to that sort of philosophical discussion of trying to argue whether these axioms are legitimate or not by understanding the concepts involved carefully enough, and then putting the right axioms down to describe what we're trying to study. The pragmatic approach is more like the fruit of the axioms is about its consequences. If the consequences are in line with what we expect or what we want to study, then that's sort of justification enough. And anyway, he's going to go back and forth and bring up these two strategies throughout the rest of the book. But it's the intuitive strategy that plays more into the kind of philosophical discussions that he wants to have throughout the rest of the book. And if you're interested in a book like this, they're also the kind of discussions that you want him to have as well to try to understand some of these choices. But then, after this discussion, he's going to build up the theory of sets that he wants to study. And he's going to start talking about the empty set and the hierarchy of sets. This is a common thing in set theory, to talk about the hierarchy of sets. One way of thinking about it is you can start with the empty set. Again, there's some philosophical questions you can ask about that I won't get into right now. But you can start with the empty set and start building up all the sets by taking power sets. So you have the empty set, then you'll have the set containing the empty set and the empty set, and so on and so, the set containing the empty set, and this, so on and so forth. And you can build up all the sets that way. I won't do a careful description of that here, but I'll do another video at some point where I demo that for you. And that's how I've seen it done in set theory courses. But there's something a little bit odd about this, which is that means that you never have the kind of intuitive sets you expect. Like, before I talked about one way you might introduce sets to somebody is talking about like a bag of marbles, right? And the bag is somehow the enclosure or the set, and then the marbles are the elements inside the set, right? In this intuitive picture. But if you build up set theory via the empty set, then it feels like there's never actually any marbles in the picture, right? Meaning there's never any like actual objects that are put into sets. They're just a bunch of collections of subsets of subsets, sets of subsets, which seems like sets of subsets of the empty set, collections of containing the empty set. Which feels like not quite what we want from set theory, or at least he argues that. So his the way he's going to formulate set theory, there's going to be the possibility for just elements that are at some ground level that can be in sets at the same sort of level as the empty set, and then we can build up sets from there. And we just like have these sort of ground elements in our theory that are not built out of the empty set. So he's going to build a theory like that, which again is not a typical thing to do. So it's interesting to see set theory presented that way. And so he's going to study the theory that he calls ZU, which has sort of less axioms in set theory than the typical treatment in a standard set theory course. So he's going to talk about ZU versus ZF, right? So he's going to, in this book, study ZU. ZF is the typical theory studied in set theory, and then ZFC, where you add the axiom of choice, is typically studied in set theory as well. But he makes this important note that anything which is this theorem of ZU, the theory that he's going to study, is also a theorem of ZF. So it's not so much that this book is a complete, other direction from ZF. It's just a more conservative approach, take slightly less axioms, allow these sort of base elements at the ground level, and see what we get from there and do these philosophical arguments, but they will still have some application to ZF, and anything we can prove in ZU is still true. So it's a reasonable approach to take in that sense. Okay, so then we move on to part two, which is called numbers. And in this part of the book, our goal is to see how we can embed the natural numbers, the integers, the rationals, and the real numbers inside of ZU, but also the same things will work for ZF. This is typically seen at some point in one's mathematical career as an undergrad student. So a lot of people are familiar with this sort of embedding into set theory, though you probably wouldn't have done it. You might not have done it at such a detailed level to have, introduced ZU or ZF into the picture or not. But then, the discussion here is we embed these things, we make some choice of the natural numbers. One simple choice to say out loud that you can do is say that 0 is the empty set, 1 is the set containing the empty set, 2 is the set containing the empty set. This is one way of describing. It's actually not the typical way in set theory textbooks, but that's one way of describing the natural numbers. 3 is the set containing the set containing the set containing the empty set, so on and so forth, right? And those are all sets inside of our theory, and we can identify the natural numbers with them and talk about how to go from, the successor function from 2 to 3 just puts another set around it. And so we can see how the natural numbers are embedded inside of set theory. But then there's this issue because there's lots of different choices. Like that, I just described to you one choice, but there's other choices you can make that would work equally well, which brings up a paper by Benacerraf that I will talk about at some point, which is called "What Numbers Could Not Be," and in there he points out the sort of arbitrariness of embedding things like this. But in this book, what Michael Potter is going to focus on is a way of trying to address this arbitrariness that we have, this choice we have of picking picking and embedding, but there's many different choices, is to show that it's categorical in some sense, meaning that you have many different choices, but you want to show that up to some structure involved, they are isomorphic to each other. And so that's really important. And so he does a lot of time studying this sort of categoricity results for the natural numbers, integers, rational numbers, and real numbers, and especially for the real numbers. And that's our way of dealing with the arbitrariness of the embedding, is just say, well, yes, there is an arbitrary choice, but at least up to isomorphism, they're all equivalent with respect to a certain structure. And so, we feel happy with that as a way of putting these mathematical structures inside of set theory. Okay, so then he moves on to part three, which is entitled Cardinals and Ordinals. This is a very, very important topic in set theory. Anytime you study set theory in any context, at some point, cardinals and ordinals will come up. Cardinals are related to the lecture I did on cardinality of sets, countable versus uncountable, and the continuum hypothesis. But it turns out that cardinals are the numbers which describe the different sizes of infinite sets that we can have, and there are a whole level of cardinals, like different sizes of sets, not just countable and uncountable. There's a whole hierarchy of these cardinals, and so the cardinal numbers have their own like arithmetic to them, and he describes all that. And then he moves on to the ordinals, which is an interesting thing because I think a lot of times books will go in the opposite order. But the ordinals are a way of it's like a hierarchy of well orderings up to order type. I won't try to describe that all here. If you've never seen it before, I'll do another video on that at some point. And so here you're going to get a lot of like typical set theory um, with when it comes to cardinals and ordinals, the same kind of things you're going to see in other set theory books, and but with some philosophical discussion in between. And then part 4 is called Further Axioms. Here he dives into the axiom of choice. He dives into the generalized continuum hypothesis and various other sort of further axioms that you can be added. And also, it's important because typically in set theory itself, the field, the mathematical field, people study ZFC. They also study lots of other things. But ZFC is very much the accepted sort of framework which we think of mathematics being done. There are plenty of people who will disagree with that choice, and there's still philosophical questions about it, but it is sort of a standard assumption that we're working in ZFC. So the C stands for the axiom of choice. So it's important to understand sort of what are the consequences of assuming the axiom of choice and what is it equivalent to. But then the last thing that he goes into is these large cardinal axioms, which are a really big, important part of modern day set theory and lots of research areas. And they were proposed. One thing that was proposed by Gödel and other people talk about this as a way of trying to decide some of these undecided results, like the continuum hypothesis. And so, you can try to add these large cardinal axioms. But this brings us back to this initial, discussion of these two approaches to how we're going to add axioms to set theory, the regressive and the intuitive. If we're going to start adding large cardinal axioms, are we going to be able to give an intuitive reason why they should exist? Or are we going to have to be forced into some kind of regressive argument saying, well, we like the consequences of this large cardinal axiom, so we're going to accept it, right? So there's lots of philosophical questions here about what we should want from set theory and how we should try to add further axioms beyond what's going on in this book. So I really liked it. If you're interested in understanding how set theory could possibly play a foundation for mathematics and some of the issues around that, this is a great book for you. Check it out. Let me know what you think. Like, comment, and subscribe, and I hope to see you at another video.